Clear? Okay. The metal. This is the oxide. Inside water. So then this is a semiconductor. So what we discussed? We discussed there are 4 regions of operations are there. One is cutoff region. Cutoff region. In this, what happens? Cutoff region. Conditions. VGS equal to 0. VGS equal to 0. VDS equal to 0. ID equal to 0. This is the cutoff region. Clear? So now come to the next step. Triode region or linear. In this, what happens? In this, VGS greater than VT, VDS greater than 0. So no, VDS greater than 0. ID equal to mu1 C ox W by N. VGS minus VT into VDS minus VDS square by 2. So now, what is each and every term you should know, right? Mu1 means mobility of electron. Mobility of electron. C ox means capacitance of oxide per unit. Capacitance of oxide per unit. So W means channel width. Okay. L means channel length. This is width. This is length. Clear? Nanometer means what? So I am saying 28 nanometer, 3 nanometer, or 5 nanometer. Nanometer means what? Nanometer means what? So we are saying I am working on this nanometer. So
10 power minus 9.
nanometer means what? That is measurement. Okay, in the VLSI. So if nanometer, someone saying, okay, this technology, this nanometer I am working. If someone saying me, it's okay. That nanometer, for suppose 5 nanometer I am working, 28 nanometer I am working. If someone says 28 nanometer chip I am working, 28 nanometer means the distance between or the length between source to drain, the length between the source to drain is minimum 28 nanometer. Minimum should be 28. So more than can be there. Okay, minimum should be 28. Less than that, fabrication people cannot fabricate. Okay, that is 28 nanometer. If suppose I am saying 3 nanometer means the source and drain distance, whatever the distance is there, that should be minimum 3 nanometer. More than that can be there. Okay, less than that, fabrication people cannot fabricate. Clear? Clear? So like this, technologies will be there. Technologies will be there. Clear? So now, so here, this is the ID current equation. VGS is greater than VT, VDS is greater than 0, ID equal to mu1 Cx, W by L. VGS means already knows. VT means threshold voltage. VDS already knows. What are the things you should know? mu1, mobility of electron, oxide per unit area, means capacitance per unit area, and width of the channel, length of the channel. Clear? Sometimes they will say width of the MOSFET, length of the MOSFET, they will say, but width of the channel, length of the channel. Remember. Clear? So this is the triode region. Third one is That one is saturation. Saturation region. In this, what is the condition? VGS is greater than VT. VDS is greater than or equal to VGS minus VT. So here one more point you can add. Okay, VDS is greater than 0 and VDS less than or equal less than not or equal to less than VGS minus VT in these conditions. Okay, so in this condition VGS is greater than VT, VDS is greater than or equal to VGS minus VT. So in this condition, what is the eddy current equation means? Same eddy current equation you can write here. Eddy equal to N T ox W by L VGS minus VT into VDS minus VDS square by 2. So now, so this is happened after the VDS is greater than or equal to VGS minus VT. Yes or no? Here the condition is VDS is greater than or equal to VGS minus VT. So now if you note down this one, VDS equal to VGS minus VT. Clear? Wherever VDS is there, keep VGS minus VT in the same equation. ID equal to N T ox W by L VGS minus VT into again VDS means VGS minus VT, right? VGS minus VT minus VGS minus VT whole square by 2. So now N T of W by N VGS minus VT whole square minus VGS minus VT whole square by 2. How this equation is looking? X square minus x square by 2. So now this equation, if you observe this equation, x square means VGS minus VT square. So what is the result you will get here? X square minus x square by 2. So you need to do LCM, right? If you do LCM, what we will get? This is 2. So what we will get? 2x square minus x square by 2. So if 2x square minus x square, what we will get? X square by 2. Yes or no? Yes or no? X square means VGS minus VT whole square. Now, next ID current equation ID equal to N C ox W by L. So we got the result, right? What is the result? X square by 2 means VGS minus VT whole square by 2. Clear? So now final ID current equation. This 1 by 2 you can write front 1 by 2 into N C ox W by L VGS minus VT whole square. This is the saturation region. Clear? This is the saturation region. We discussed 4 points. Fourth region is breakdown region. Breakdown region. What is the breakdown region means? Breakdown region. In this region, VGS is greater than VT and VDS is greater than VGS minus VT. Getting more. It is double times of VGS minus VT. When double times it is happens, what happened? So so double times when it is there, what happened? The depletion region keep on increases like this, like this. Okay. So this will also have one depletion region, right? This also will have one depletion region. This one also have one depletion region. This radius increasing keep on will cause this depletion region increase. So at one point, what happened? This both depletion region will be merged. Both depletion region will be merged. So then what happened? Both depletion region will be merged. So high current, high amount of current will be, high amount of electric field will be generated. So that electric field cause high amount of current. So that current will break down the transistor. There are two types of breakdowns will happen. One is Zener breakdown. First happens will be Zener breakdown. So then avalanche breakdown will happen. Zener breakdown it will happen. Okay. So if we reduce the VDS, again we can use this transistor as a same that functionality. If avalanche breakdown happens, so we can't use this transistor again. Same functionality we need to throw into the trash. Clear? So breakdowns will be there. So what are those breakdowns? Zener breakdown. Avalanche breakdown. If you know Zener diode, you know Zener diode? No.
Yes, sir. We know.
Voltage stabilizing purpose. Okay. So Zener diode will use for voltage stabilization purpose. No. Zener diode. Guys, you are not from MS, right? BW, right? See, if
Sir, we know,
anyone
sir.
is from MS or some other background, please let me know. Okay. Okay. Okay, fine. At least. So if something will be there, right? See, on the board something will be there to write in that, okay, will be become difficult. I need to erase and I need to write. Nothing will be there, empty page, I can write whatever, so you will get those things. Clear? Yeah. So this is the summary. 4 regions will be there. Cutoff region, saturation region, triode region, and breakdown region. Cutoff region ID current will be 0. For suppose any case, in this any case, VGS is not greater than VT, less than VT. So then that is by default cutoff region. VGS less than VT means cutoff region. You can remember like that. Later when come to the short channel again, I will change the definitions. For now only these are clear. So little bit things will change and a little bit points will add. So now, so at starting I told, these base and source need to be connected. So now, why we need to connect? So now see, why we are connecting this one means, this one is a N material, this one is a P material. That's all. So how it is looking? N material is there, one P material is there, N is source, P is a bulk. So if bulk get positive than the source, bulk get positive voltage compared to the source. Source is using for negative terminal, negative connection. Okay, so bulk gets some positive voltage. For suppose consider bulk 0 only, bulk voltage 0, but source voltage is -10. What is the potential difference between these two? 10. Yes or no? So what is the potential difference? Potential difference means what? VBS. VBS equal to VB minus PS. VB is
Yes.
0. Minus VS is
-10.
minus 10. So then result will be 10. So if positive voltage, if you will apply for PN junction diode, P is positive, N is negative, what happens? What happens? Forward bias. Forward bias, what happens? The forward bias, what happens? The electrons will be moved from here to here, right? Yes or no? Electrons moves
Yes, sir.
here, this direction. So then current will move opposite direction. Getting? This is not our transistor functionality. Our transistor functionality is the current should be, the electron should flow from this source to drain. Current should go from drain to source. That is the transistor functionality. This whatever will be happening, right? This is one of the effect of the short channel effect. So that is a body biasing effect. Body biasing effect. Clear? Just I given brief introduction. That's the reason we connected this one. Okay. Detailedly we'll discuss in the short channel effects. Body biasing. For now, just why we are connected, I am giving that. Clear? Now see, we'll see the characteristics. So then you will understand again. Few more points I will add. So now characteristics, if you observe. So I am drawing a characteristics between ID current, okay, ID current and VDS between ID current and VDS. So what happens first cutoff region? If VDS is 0, current will be 0. Even VGS is present. Okay. If keep on VDS, if I will increase, what happens? This is for suppose
It will increase.
0.1, 0.2. Keep on I'm increasing. It is starting linearly. Yes or no? After that,
Yes, sir.
certain time it will become non-linear because of the channel length reduction, pinch off is happening. So these all things it becomes non-linear. From here it will become non-linear. This is non-linear. Even though current will increase, non-linear case. After that, it will go to the saturation. It will go to the saturation. So now, so up to here to here, whatever the range is there, this will be linear. So this why up to here, whatever is there, this is non-linear. So this one is saturation. What is the condition for saturation? Condition for saturation is VDS is greater than VGS minus VT. VGS minus VT. First, suppose consider my VGS is 2 volts. Okay, 2 volts. My VT is 0.7. 0.7. I applied VGS is 2 volts. My VT is 0.7. So then when it will go to the saturation? 2 minus 0.7, 1.3. If I will apply VGS is more than 1.3, it will go to the saturation. Means current becomes constant. Yes or no? Now what I did, instead of 2, I applied 4. VT will be same, right? So no, VT is same, 0.7. So now, so what is the voltage we get? Result 3.3. Means now I need to be applied to make it is to be saturation. I need to apply more than 3.3. Observing what you observe. If VGS I am increasing, what happening? The current reach to the saturation point is increasing. The current reach to the saturation point is increasing. This is with values I am saying. Okay. In the operation, if you want to show in the operation how you will show, now see. This is the channel, right? So now I am increasing the VGS. Focus. So now the number of electrons injected is increasing here. Number of electrons injected increasing here. So then what happens? VGS previously 2, now I am making double 4. 4 means previously 1000 electrons are injected. Now what happens? 2000 electrons will inject. 2000 electrons are injected. The width of this channel will be increased. The width of the channel will increase. The width of the channel is increasing. The number of electrons which carry the charge will increase. Yes or no? The width of the channel is increasing. The number of electrons which carry the charge will increase. That's the reason. To reach the saturation, it will take more time than the less VGS. Clear? So the width of the channel increasing and making the ID current equation reach to the saturation point late. So the width of the channel increasing will call the enhancement. Clear? Enhancement. VGS causes enhancement of the channel. Enhancement means what? Increasing the channel. So that's why we will call this one is a enhancement MOSFET. Ready? The operation, each and everything will be there in the name itself. If you observe properly name, enhancement and MOSFET we call. Enhancement means, so based on the VGS supply, the channel will be enhanced. Clear? So that is the one thing. After that, N MOSFET means it is channel is N. Some channel forming there will be N material. N MOSFET means N channel. MOSFET means metal is there, oxide is there, semiconductor is there. Clear? So that's why they will call this one is a enhancement and MOSFET. Clear? So now this is the story. So yeah. So this is a saturation point. Based on this observation, what I can say is, if I will, this is for suppose consider VGS equal to 2. So now this is VGS equal to 4. This is VGS equal to 6. Like that it will increase. Clear? Note down. These characteristics, what is the name of these characteristics? Drain characteristics. Okay? Drain characteristics. So in the drain characteristics, ID versus VDS will draw. ID will be in the y-axis, VDS will be in the x-axis. The values are positive, that's why we will take in the first quarter. 4 quarters will be there, you know, right? What are those? 4 quarters will be there. These are the 4 quarters. So whatever this we draw, this is the first one. Okay. VDS is positive, ID also positive. If VDS is negative, ID positive, so then this is the second case. Ready? Third case VDS. So third case is VDS is positive, ID is negative. This is the third case. Both are negative. This is the fourth case. Ready? 4 quarters will be there. This is the first one. Understand, right? Drain characteristics. So next, transfer characteristics. Transfer characteristics. In the transfer characteristics, okay, we'll draw between VGS and ID. ID. Clear? VGS is 0. VDS also 0. Current will flow? No. So after, okay, certain point, okay. So VGS, suppose this is a threshold VT point. After VT only current start flows, right? After this VT, keep on increasing slowly, current will increase like this. Yes or no? Yes or no? So this is a VDS 1 point. VDS equal for suppose 1 volt. For suppose example. So if suppose I increases VDS more, so then how it will be, current will be more, right? Like that it will be. After VT only current will start flowing. Clear? So this is the transfer characteristics. Last assignment completed.
Yes, sir.
Okay, what are the questions I given last assignment?
So it's
If current, diffusion current, have I told?
Yes,
Told us?
yes, sir.
Explained. I explained or not?
Not explained, sir.
Not explained, right? So what is the difference between drift current and diffusion current? Anyone?
Diffusion current means electrons passing from low concentration to high concentration. Sorry, high concentration to low concentration side.
Diffusion or drifter?
Diffusion.
Yes. Diffusion will be higher concentration to lower concentration or lower concentration to higher concentration. Means based on the concentration, whatever current flows will be there. So that current will call the diffusion current. Diffusion current. Okay. So drift current means based on the external force, whatever current flow will happen, right? That current flow will call the drift current. Drift, lift. Okay, external force will required to be lifted. Like that you can remember. Okay, drift current. Diffusion means higher concentration to lower concentration to higher concentration. Okay, so if someone will ask, okay, in no equilibrium condition, which kind of current you can observe? What kind of current you can observe? No equilibrium condition. Okay, equilibrium condition. No supply is there. Okay, you are not given any anode cathode supply to the diode. So which kind of current you can observe? Diffusion current only, right? So we have more holes and you have more electrons. Hole speed will goes towards the N side. Electrons will goes towards the P side. Yes or no? Because of momentum of those things, what happens? What happens?
Diffusion current will generate.
Diffusion current will happen. Diffusion current will flows. Yes or no? Electron moving from one place to other place. Current will flows. No doubt in that. Getting? So there, which current presents? Diffusion current presents. Okay. These all things are very important. Now it's like okay, fine, small point. When added next topics, okay, so digital, linears. So after that RTL, after that DFT, logical synthesis, physical synthesis, PLR inputs, placement, CTS, routing, sign off. So then advanced PD concepts, then timing fixes, STA concepts. These all things when we discuss, right? So then this drift diffusion will come. Okay? So that's why we call revision the things. Clear? So this is the one question. So what is the other question?
MOSFET and BJT.
MOSFET and BJT. What are the difference?
Current control device of BJT.
BJT is a
Current
current control device that I already told. So MOSFET is a voltage control device. Okay. So next, second difference.
Low impedance.
Low input impedance that I already told. Okay, high input impedance.
More from
See how I am saying high input impedance. See, don't imagine something whatever I told. So you should check the design itself. See, this is the plate. This is the semiconductor. Between anything supplies. Why? No. Because of the capacitance effect, it is transferring the charge. That's it. But IC current, have we discussed anything related to IC current? IC current, what is the value of IC current here? Zero. IC current is zero. IC current when it will be zero? ID current when we are saying zero? Two diodes are connected back to back, creating the high impedance circuit. So then I am saying that will be zero. Here, how IC current is zero? Because of this dielectric material, because of this oxide, what happening? It is creating high input impedance. That's why it is high input impedance. Clear? So remember this, very important. Clear? So any point you need to be refer the diagram. By seeing the diagram itself, you should know the points. Okay. So now next.
BJT is bipolar and MOSFET is unipolar.
Unipolar, bipolar, unipolar. So unipolar means what? Here current is flowing. What have I told? Okay, hole because of the holes current is flowing. In N channel MOSFET, have I told any holes? Have I included any holes? Only electrons. Because N channel, electron channel. Okay, that's why. So only electrons will be participated in the N channel. When come to the P channel, means P MOSFET, only holes will participate. Electrons will be not participate for current flowing. Clear? So this is the difference. But BJT it's not like that. Electrons and holes both will participate. Okay, that is the thing. Next,
Salil sir,
BJT
sir,
BJT
application
occupies more area. So MOSFET of fabrication will be very easy and less area also. Next, amplification purpose, digital switching purpose. Okay, next,
BJT is switch speed is low,
okay,
MOSFET is high, and
BJT
BJT is
speed will
high
be
power
low
consumption.
compared to the MOSFET. Okay, BJT switching speed will be low compared to the MOSFET. Some people say they will ask in the interview in different ways. Okay, so they will ask in MOSFET, we'll see two kind of field effects: vertical field effect, horizontal field effect. Can you please tell me the names of those field effects? They will ask. Vertical field effect, horizontal field effect. When sir is explaining, he don't told what is vertical field effect, what is horizontal field effect. The whatever the VGS field effect is there, this is the vertical field effect. So no, it is attracting the whatever the electrons towards top side. It making to be all to be comes to the surface. Getting? This is the vertical field effect. So if someone asks what is the vertical field effect, VGS. Horizontal field effect is VDS. This both will present, this both together, then only current will flow from the VDS to VD to drain to source. Electrons will move from the source to drain. Clear? Different ways, different cases, different different terminology they will use and they will ask the questions. Ready? So you should ready for
Sir.
any kind of question they will ask. Yeah. Next. No. What else are we? What other things are you saying? Right?
Sir,
Yeah.
sir. Yesterday you said that deposition of electrons in an upside between N fusion, right? That P side, which substrate electrons in P substrate, the electrons in P substrate will be deposited in that between N plus diffusion is there, na? There.
Sorry, what is
Yeah.
there? Your voice is not
అక్కడ
clear. Don't write anything. If you write anything on board, it will be not removed by me. Sorry, can you repeat the question?
సార్ పీ సబ్స్ట్రేట్ లో ఉండే ఎలక్ట్రాన్స్ వెళ్ళి అక్కడ ఎక్కడైతే మనకు ఎన్ ఎలక్ట్రాన్స్ ఉన్నాయి కదా ఇక్కడ ఎన్ డిఫ్యూజన్
The
దగ్గర
magnetic
middle లో
carriers
place
of electrons, whatever is there, the electrons,
Hmm.
magnetic carriers of electrons, this will go participate in the channel.
కానీ
Where-
మనకు తెలిసిన రూల్ ప్రకారం ఎలక్ట్రాన్స్ రిపుల్ ఇచ్చి కదా సార్ మరి ఎలా డిపాజిట్ అయితే అక్కడ
Sorry?
This repulsion, sir.
Yeah. So repulsion should happen,
రిపుల్
right?
ఇచ్చేది
So
Ah.
with the which you are checking? With which you are
Which one?
checking? Now question is, okay, this force is attracting, this force is attracting the electrons. Okay, this force is attracting these electrons as well as this electron. Okay, so now these electrons moving towards this side. This electron will repel to this electron, or this electron will repel to this electron. Which electron will repel? This electron will repel to this electron, inside electrons. Get it? This electron will repel
Okay.
inside electron, this will go forward. Get it? Get
Yes,
it?
sir.
So when I explain here also, the electrons will be, these electrons will repel these electrons. Not these electrons will repel these electrons. Because the force is coming from negative direction.
VGS.
So how the source is injecting the electrons, the same way bulk also, right? The same way body also, right? The same way substrate also, right? Getting? So these electrons will repel these electrons, not opposite direction. Clear? Okay. See, and one more thing. When you are imagine this one, so people will imagine like this. It's not like that actually. So actually it will be like this. So if suppose this is a substrate. Okay, this is a substrate. One diffusion will be here. One diffusion will be here. Okay, on top of that, metal plate will becomes. Okay, metal plate will becomes. Getting? So if from here metal plate they will take. Okay, oxide will be there. So they will take the one metal pin, here diffusion pin, here diffusion pin. Getting? 3D you need to be observed. This is 2D. When I'm explaining, you will feel that okay, these ends both are in top. No, these are like a well. Getting? It will be inside. Inside. When you are imagining, so you should imagine like this. So if you imagine like this, then here what happening? So it is like this, current is flowing, but here current will flow like this. Getting? So you should imagine like this. Then you will know. Means what happening? This see. One more one is there. Okay. Something else will be there. So then see, actually how it will be, one material will be there. That material they will cut from the top. They will cut and they will make a. See, actually this is the material, complete piece substrate if you consider. They will cut and this one cut will be, they will make source or right. This is a source. So they will make like this. So now this is inside this substrate. This whatever these ends are there, those are inside. Okay. This channel whatever forming, that is also inside it will form. When inside channel is forming, inside electrons will come to top. Holes will go to bottom. Getting? So if you imagine like that, then you will get the clarity. If you imagine like this, then you will not get the clarity. If you go to the YouTube videos and check 3D images, so then you will get more clarity on this. Getting? So you are inside current is flowing here. Means inside channel will form. So the way when we are explaining, you will feel like in top, it is forming at top. No, it will form inside. Getting? The difference is there. The imagination is required. Very careful. So now the same way, how the enhancement MOSFET is there. So I will give go with same enhancement and MOSFET is there, right? Same P MOSFET. Go with that. Take the as assignment question. Go with that. What is the conditions and things? Let me know. Tomorrow we'll discuss enhancement P MOSFET. So now we discuss depletion MOSFET and enhancement MOSFET difference. Clear? We'll discuss now enhancement depletion MOSFET differences. So you should go with, we discuss N channel enhancement MOSFET. So now you should go with P channel enhancement MOSFET. Okay. So that is the assignment question. So conditions, I required conditions. ID current equation. So what is the cutoff region? What is the linear region? What is the saturation region? And what is the breakdown region? These conditions are required. Okay. So go with these things. So now keep a heading. Keep a heading. Keep a heading. Depletion MOSFET. Depletion MOSFET. Depletion MOSFET. Now, here we did lot of things to form the channel, right? But here it's not like that. Here, if suppose same N channel, if I will consider, so if you see, observe, have you see any differences? Have you seen any differences? Previous diagram, this diagram. I am saying this is a depletion MOSFET. How? The depletion MOSFET, what happened? Even VGS equal to 0, channel present. Channel present. VGS equal to 0 also channel present. Means this channel, okay, when fabrication happened, okay, diffusion they will insert, right? Channel also they will insert. Getting? Channel also they will insert. Clear? Previously what we did? We found the channel applying VGS. But here already channel is present. Did it? Already channel is present. So now if you apply VGS is negative voltage, so then channel will be decrease. Getting? Channel will decrease. If you apply more VGS voltage, channel will increase. Getting? Channel enhancement will happen or channel decrease will happen. Here VGS you can apply negative and positive both. Getting? The main difference between enhancement MOSFET and depletion MOSFET. Enhancement MOSFET, we need to apply VGS voltage. That VGS voltage should be greater than VT. So then channel will form. Means inversion, strong inversion, these all should happen. But here when fabrication they are doing, when they are doing in diffusions, so then only they will create the channel. Fabrication people itself, they will create the channel. So now example, best example, if I want to say is, okay, if I want to say is, this whatever home application, whatever switches we are using, that is like an enhancement MOSFETs. Okay, home bell will be there. Bell, what happens? If you press only, it will be right. It will be turn on. If you leave,
Turn on.
off. Always on off. Sun off. So quite opposite you need to remember. So always it will turn on. Getting? You need to off, you need to apply VGS voltage negatively. Always, this is by default it will turn on. Channel is ready. If you apply VDS, now the condition VGS equal to 0. VDS is greater than 0. Current will present or not? Definitely current will present because channel is there. Depletion MOSFET. Yes or no? It is already ready to conduct. If VDS is present, current will flow. Ready? Ready? This is always on switch. Depletion MOSFET we can also say always on switch. No doubt. Depletion MOSFET we can also say always on switch. Always on switch. The difference between depletion MOSFET and enhancement MOSFET is depletion MOSFET channel will be formed when fabrication is happened. When fabrication is happened, enhancement MOSFET channel will form based on the supply VGS given. Okay, that is the main difference. Remaining all are same. Operation, everything. So if you apply VGS is positive, channel will be depth will be increased, width will increase, current will increase. If you apply negative, channel will be decreased. Channel will be decreased. So then current will be decreased. So if you keep on going, certain condition VGS is more negative. So then what happened? Channel becomes. There is no channel also will be happen. Means there is no channel. Completely it will go to turn off. Getting? So here to turn off we are applying the supply. Getting? So here source will be positive, gate will be negative. How it will work I will tell you. If negative voltage I am applying, channel is already formed, so I need to apply negative voltage to turn off this one. So when I am applying negative voltage to turn off this one, so then what I need to do?
Positive to source.
Source will be positive.
Negative.
This is VGS. VGS is negative here. Ready? Now what happened? This gate will get negative charge. Yes or no? Oxide have positive and negative. Negative charge will attract positive top side. Yes or no?
Yes,
Yes or no? Negative bottom side. Yes or no? Now this will be repel the electrons, attract the holes. Attract the holes, repel the electrons. So holes are going top side, repelling the electrons. What it will happen? Electrons will go to this side as well as this side. So when it will go this side, what happens? It is here positive charge is there. Yes or no? Here also positive charge is there. Yes or no? So this complete will be goes and depositing this positive charge up to certain region. After that, keep on electrons are moving from in this area. Finally, what happens? There is no electrons. Then electrons further it will move. No, right? Then current will be present. No. So that is the thing will happen here. Clear? Any questions? Any doubts? Depletion MOSFET. If you know one thing, the enhancement and MOSFET properly, remaining all things are released. Clear? This is the thing, no doubt.